All right, so we are going to look at the basic trig identities. And all a trig identity is, or all an identity is an equation where both sides are equal no matter what you put in. Basically, that's what an identity is. So there's different ways to write true statements, right? I can write something and it can be equal to something else, and we're going to try and simplify things. It's going to be a way that helps us simplify trig either equations or oh my God. What is it when it's an equation, but it's not doesn't have an equal sign? Expression. Good Lord. Okay. Simplify expressions. Those are the ones that don't have the equal signs. So we have certain identities. You already know a lot of these. Okay. The reciprocal identities are basically these. If I have the sine of theta, okay, what is sine the reciprocal of? Cosecant. Good. So sine theta equals 1 over cosecant theta. Does that make sense? That's one identity. That's one reciprocal identity. You know that those two things are equal. They could be used in place of each other in an equation. Make sense? Okay, so if that's true, if I take this and I multiply both sides by cosecant, right, then that means that sine theta times cosecant theta has to equal what? 1. Then, if I take this and I divide both sides by sine theta, then cosecant theta is equal to 1 over sine theta. So those three kind of go together. It's like a little family. I don't know if you remember if you had like word families or number families in elementary school, but all you really have to understand is this one, and then this right here makes the rest of it true. You see how that works? Okay, so those are all basic things that you have to understand about how those get along. So then we have cosine theta. That's equal to 1 over what? Secant theta. Good. Which means that cosine theta times secant theta is equal to 1. Then we also know that secant theta is equal to 1 over cosine theta. And make sure you're writing this where you can read your own handwriting, because you're going to need to refer back to this. So then we've got sine, cosine. Now we need tangent theta. That's 1 over what? Cotangent theta. So tangent theta, cotangent theta equals 1. And cotangent theta equals 1 over tangent theta. So those are the relationships for your reciprocal identities and how they relate to each other. Okay. Everybody good so far? All right. Any questions? So now let's look at our ratio identities. What is a ratio mathematically most of the time for us? A fraction. Okay, so ratio identities. So we know already that tangent theta is equal to what fraction? Sine over cosine. Good. So sine theta over cosine theta. So there's another one that you really already know. Okay? We just haven't used it in the manner that we're going to use it yet, but we already know that. Now, you can square these things. We haven't looked at them squared yet, but we're going to. When I take tangent theta and I square it, okay, it's like tangent theta squared, then the way we write that is tangent squared theta. So basically that's just tangent theta times tangent theta. Okay? So if tangent theta equals sine theta over cosine theta, then what do you think tangent squared theta equals? Sine squared theta over cosine squared theta, right? Because when you square a fraction, you just square the numerator and denominator. So tangent squared theta is equal to sine squared theta over cosine squared theta. Everybody okay with that? All right, so then another ratio identity, cotangent theta. So what do you think that fraction is going to look like? Cosine over sine, because cotangent is a reciprocal of tangent, so this is cosine theta over sine theta. Everybody okay with that? Which means then that cotangent squared theta is cosine squared theta over sine squared theta. What did I do? Isn't what cosecant? Would what be cosecant? The cotangent? No. We're just, cosecant was the reciprocal of sine. Cotangent is a reciprocal of tangent, so it's just the reciprocal of this fraction right here, which gives me this. Now I could write this as as the fraction of cosecant theta over, no, as secant theta over cosecant theta. I could write it like that too, like those are things that I could substitute in because, oh no, I'm sorry, I said that backwards. It would be the reciprocal. This would be cosecant theta over secant theta because of the reciprocals. Those are true also, but we're not going to write every single possibility down there because that's how you end up substituting things in and manipulating it around. Does that make sense to you? That's a good question. Okay. Anything else? So yes, cotangent theta could be equal to a different fraction because you could put these reciprocals in there, but we're not doing that right now. We good? But that's how you end up substituting things and manipulating it to get it to the point of where you want it. Okay. And after we get all these identities down, then we will look at what we're going to do with those. All right, so then we have Pythagorean identities, and there's actually 3 of those. And these, instead of just knowing how we come up with them, oops, we're going to look at where they are coming from. So up here at the top, I'm going to draw just the first quadrant of the unit circle, okay? And I'm going to draw in a triangle. Okay, so remember when we did at our unit circle, right? That angle right there is our theta. What is this length right here? 1. It's the radius, and then if it's the unit circle, it's 1, so r equals 1. This is our x value, and this is our y value, right? And what is x? Cosine or sine? Cosine. So this is cosine theta, and this is sine theta. Right? So I know from the Pythagorean theorem that a squared plus b squared equals c squared, and in this picture right here, x squared plus y squared equals 1 squared, right? What's 1 squared always? 1. So since x squared plus y squared equals 1, then cosine squared theta plus sine squared theta has to equal what? 1. And that's straight up just right from the Pythagorean theorem and right from your unit circle. So our first Pythagorean identity looks just like that. It is cosine squared theta plus sine squared theta equals 1. Okay. So to come up with the other 2, we're going to rewrite that one. Cosine squared theta plus sine squared theta equals 1. And then we're going to divide each term by cosine squared theta. Okay. So I'm simplifying this. I'm going to divide it all through by the cosine squared theta, and then I'm going to simplify. So what's cosine squared theta divided by cosine squared theta? 1. Okay, so this gives me 1 plus, what else could I put instead of sine squared theta over cosine squared theta? Tangent, good, and it's tangent squared theta equals, what's another way to write 1 over cosine squared theta? Secant, good. So secant squared theta. So when you simplify these, you don't leave anything in the denominator like that, right? If you can write the ratio, you write the ratio, but not being in 1. Now, since 1 plus tangent squared theta equals secant squared theta, do you think that 1 plus tangent theta equals secant theta? Can I just like take the square root of the whole thing and just say 1 plus tangent theta equals secant theta? No. Just like here, I'm not saying that cosine plus sine equals 1. It's cosine squared plus sine squared equals 1. right? So any of these that where you're adding stuff with the 1, it's got to have the squareds in it, okay? We good? Any questions? So now we're going to rewrite that one more time. So cosine squared theta plus sine squared theta equals 1. And we're going to divide each one of these this time by sine squared theta. So what's another way to write cosine squared theta divided by sine squared theta? Cotangent. So this is going to be cotangent squared theta plus what? 1 equals what? Cosecant squared theta. So these two things that we wrote right here, this was just work to help us get to that point. These are your 3 Pythagorean identities, okay? But I wanted you to see where they came from and not just give them to you. Now, when you're trying to remember them, I think this one right here, not that big of a deal, right? Cosine squared plus sine squared equals 1. That's just exactly like Pythagorean theorem. Then when you're trying to remember which ones of these get matched up and which order things go in, notice that when you add the 1, both of them are the tangent ones, right? It's either tangent, 1 plus tangent squared or cotangent squared plus 1, but I'm not adding 1 to the secant or the cosecant. You with me? And these are both of the cos together, and these are the 2 that don't have the co together. Does that make sense to you? So, some way to kind of look at what's happening and make sure you can keep it straight so you don't get it all mixed up about which ones go together, right? And they, just like anything else, the more you use it and the more you look at it, you'll know it and understand it better. And, if you need to make yourself flashcards or whatever, that's always fine. You do what you need to do for you, but you'll sort of learn how they work together, okay? Now, I know this is on the front. You're going to have to keep, like, flipping back and forth, but we're going to use that to help us work through these next problems, right? So some of them are super easy and straightforward. Some of them, take a little bit more work, but all of them require you to show your steps. Your steps in your process is part of it. Even if you can look at it and already know what it's going to be, just like anything else, you kind of have to show your work. The process is part of the answer. So it says use the basic trig identities to simplify each of the following to a single term. Okay, so we're going to get these all down to a single term. And like a lot of things, sometimes we have to all start one way. Sometimes within it you could go different directions and we should all end up at the end with the same thing. It's just like any other kind of proof or whatever. Sometimes you could take the long way, but you can still get there. Because one of the things that's going to, if you struggle with it at all, is going to be struggle with how do I know what I'm supposed to do? Well, you just get in there and you do what you can do and you realize that didn't work and sometimes you got to undo it. But here I've got to multiply these, okay? So this is, I'm squaring these. This is going to be a difference of 2 squares, right? So a lot of times when I multiply 2 binomials, I get a trinomial. Am I going to get a trinomial here? No. I mean, if you FOILed it out, what's sine theta times sine theta? Sine squared theta. So I get sine squared theta. And then we should just know, because of our rules, that we're just going to get the the minus 1. But if I did FOIL it, I'd get negative sine theta, positive sine theta. That's why it goes away, right? And then negative 1 times 1 is negative 1. Okay, so that's what this equals. So sine squared theta minus 1, what is that the same as? Look on the front there. Or actually, just what could I replace sine squared theta with? What could I replace sine squared theta with? I could replace it with secant squared theta. With 1 over cosecant squared theta, but I don't know if that's going to help me. But look at this right here. If I have this, sine squared theta would be what? 1 minus cosine squared theta? Y'all okay with that? Okay, so instead of sine squared theta, I'm going to do 1 minus cosine squared theta minus 1, because I still have to have that minus 1 there. Everybody good with that? What does that simplify down to? What's 1 minus 1? 0. And then, so that just leaves me with negative cosine squared theta. And that is my answer. Okay? These are like puzzles. They're fun. Okay? You'll like them. Won't be that bad. Everybody good with that? All right. Now, let's look at number 2. When I multiply these together, this is going to give me cosecant squared A, then what? Minus 1. Okay? So cosecant squared, what do I replace cosecant squared with? Cotangent squared plus 1. Good. So this is going to be cotangent squared A plus 1. That's what I'm replacing cosecant squared A with. Minus 1. So that 1 minus 1 is just 0, so I get cotangent squared A. And I have simplified that down to one term. Okay? Any questions about that? Okay. All right. Let's look at number 3. Got cosecant squared x times 1 minus cosine squared x. Okay. So we can do a couple of different things here. If I can go ahead and distribute that in there, and that's fine. If I do that, then I don't really have anything that's cosecant squared times cosine squared, do I? No. Could I get a reciprocal in there somewhere? What's cosecant squared? What's the reciprocal of that? 1 over sine squared, right? Well, if I do that one and then I multiply that in, is cosine squared over sine squared something at least? Yes? Do y'all agree with that? Okay. So if we did that, let's make that 1, let's go ahead and we're going to change this to 1 over sine squared x. That make sense to you? Times 1 minus cosine squared x. Well, what could I substitute 1 minus cosine squared x for? Anything? Sine squared x? Y'all agree with that? Okay, so this is equal to 1 over sine squared x times sine squared x. So what does that equal? 1. When I initially did this problem, I had a couple extra steps. I distributed this in, and so that I ended up with 1 over sine squared x, and then I got a common denominator, and then I ended up in 1, but it took me longer to get there. Could I have done some different things? Could I have made this 1 over secant squared x and then gone that way? Yes. Could I have, there's some other things you could have done, but eventually you would end up with 1 even if it meant more steps. Does that make sense to you? So you see how you just have to look at it and go, okay, what could I put in? Could I substitute anything in there that would help me? What's going on with this and whatnot. Okay, we good? All right, so let's look at this one. We've got sine of x times cosecant x minus sine x. All right, so if I distribute that in, I know I'll get a sine squared x in there somewhere, so that's decent. What's the reciprocal of cosecant? What is it? Sine, okay? So that might help me if I wrote that as 1 over sine x. Do you agree with that? So I'm going to rewrite this and get sine of x times 1 over sine of x minus sine x. Now, sometimes when you have more than one term, the best thing for you to do is combine them and get a common denominator, but that may not be what would be the best thing at this step. Since I've got something I can distribute in, I think I'm just going to go ahead and do that. So this is going to give me, what is sine x times 1 over sine x? 1 minus sine squared x. Right. So then, what's 1 minus sine squared x? Cosine squared x. Any questions about that? All right. Let's look at number 5. I worked number 5 a couple of different ways. I was trying to figure out what All right, so I have tangent of x plus cotangent of x. If you have something that's not squared, does the adding or subtracting really directly get you anything? Or anytime you added or subtracted with your identities, if you look at them, you always had the squared in there, okay? So you want to make sure that you're thinking that way. But I can get this tangent x plus cotangent x. I know that those are reciprocals of each other. So regardless of whether I do it first or last, I can actually add those together and get a common denominator, which could help me figure some other things out here. Because if I take the reciprocal, what's the reciprocal of secant squared? The reciprocal of secant is cosine, right? So I could multiply this by cosine squared, but I don't know that that would get me anywhere either, because then that's just a whole lot of stuff being multiplied together. So let's take this and see what we can do with the numerator. I'm going to leave the denominator the same right now. Just leave it as secant squared x. And then I know that tangent of x plus 1 over tangent of x, right? Does that make sense to you? Because it's a reciprocal. Now, if I add the two things together in the numerator, then I need a common denominator. What would my common denominator be? Tangent of x, right? So I'm leaving the denominator the same, just kind of ignoring it for right now. But in the numerator, I'm going to get a common denominator, and it's going to be tangent of x. Well, this is like tangent of x over 1, right? So to change this to get a common denominator, what is it going to look like? Tangent squared x over tangent x plus 1 over tangent x. Everybody okay with that? So then that's going to become tangent squared x plus 1 over tangent x all over secant squared x. Right? Okay. Any ideas on what might be helpful to change next? Look at your identities, so it's not just me walking you through it. What do you think would be a good substitution here? What? Secant squared. What would I replace for secant squared x? Tangent squared x plus 1, because you have tangent squared x plus 1 equals secant squared x, right? So that's good here. So now that means I'm going to replace this. This is going to be secant squared x over tangent x divided by secant squared x, right? So if you don't know how to just fix that, if that whole fraction thing still, you have a fraction divided by something, when you divide a fraction by anything, you're multiplying by the reciprocal. So if I take secant squared x over tangent x, dividing it by secant squared x is the same as multiplying it by 1 over secant squared x. And when I do that, what happens? The secant squared x's cancel out. So that leaves me with 1 over tangent x. And what's 1 over the tangent of x? Cotangent x. Could I instead have changed this right here to tangent squared x plus 1? I could have, right? And then that means that's what this would have been. These would have stayed that, and those two things still would have canceled out. So it's not like you have to substitute it in exactly like what I did, but what you do does have to make sense logically from the identities, okay? There are different ways to approach it, but eventually you should get there. Yes, sir? Say that one more time. No, you need to get it down to not being in the denominator if possible, yes. Just like even this could be cosine x over sine x, but that wouldn't be simplified all the way. Technically, that's one term also. It says down to one term. The cosine over sine is one term, but you don't want it to be a reciprocal if possible. That's a good question. Do they have the same value? Yes, they do, but this is what we're aiming for here. Anything else? We good? Okay. All right. So let's look at the next one. All right. So I'm going to have to square both of these binomials, right? So when I do that, because, I mean, I could change things out right now, but if things are in sine and cosine, that's usually one of the easiest things to use, so I don't want to change it out of that just yet if I don't need to. So I need to square this. This is going to be a whole lot of writing across it here. So when I square this one, that's going to give me sine squared x, right? Then what would come next? Cosine, it would be 2 times cosine x sine x, right? Because we know how to FOIL things, right? You're squaring a binomial. It's this squared plus 2 times these two squared plus cosine squared x. We agree with that? That should be a no-brainer at this point, right? Then when it's the difference, that's still going to give me sine squared x, but then what? Minus 2 cosine x sine x plus cosine squared x. So that's a lot of stuff, right? But then I want to combine my like terms. So I can combine sine x, and that becomes 2 sine squared x. Then I have this positive 2 cosine x sine x and a negative 2 cosine x sine x. So what happens with that? They cancel each other out. That's beautiful. Then I've got these two, so it's going to be plus 2 cosine squared x. Everybody with me? Now, do we have anything that looks exactly like that in our identities? We have nothing with a 2 in front of it, right? But can I factor something out here? Yes, I can factor the 2 out. So 2 times sine squared x plus cosine squared x. And what is sine squared x plus cosine squared x? 1. So that's 2 times 1, which is just 2. All that mess, and your answer is 2. All right. Any questions at this point? All right. So let's look at this last one. All right. So could I replace cotangent squared x with something? Yes. With what? What would cotangent x, or cotangent squared theta be replaced with? It would be cosecant squared minus 1, right? Does that really look like it would be that helpful at this point? Not really. Looks like it might actually confuse me because I couldn't cancel anything out with the denominator, right? But then I have this. What is sine theta times cosecant theta? One, right? And if you need to, like, that is an identity. But if you're not sure about that, you can rewrite it. Let's go ahead and do that. So I could say cotangent squared theta over 1 plus cosecant theta plus, this would be sine theta times 1 over sine theta, right? That's why it equals 1. So those cancel out. So you actually get cotangent squared theta over 1 plus cosecant theta plus 1. All right, so I now have this. I would like to be able to add them together, so I need a common denominator. What would my common denominator be? 1 plus cosecant theta, yes? So this is going to give me cotangent squared theta over 1 plus cosecant theta plus 1 plus cosecant theta over 1 plus cosecant theta. So now that I have that, I'm going to go ahead and combine them. So this is going to give me cotangent squared theta plus 1 plus cosecant squared, I'm sorry, just cosecant theta, all over 1 plus cosecant theta. Everybody understand where everything came from? So I got my common denominator. Sometimes things get worse before they get better. So it looks yuckier, but I've got that cosecant in the denominator. I have 1 in the numerator. Do I get to just like cancel these out right here? No, that didn't work that way. But what is cotangent squared theta plus 1? Cosecant squared theta. All right, so even though I didn't think that would have been like a -1 earlier, right now I think that might actually help me. Cosecant squared theta, that takes care of all of this right here, plus cosecant theta all over 1 plus cosecant theta. Now remember, our goal isn't just to rearrange things and simplify them. It's to get us down to one term. So at this point, oh, my watch is way off. At this point, what do you think I could do that could be helpful? Any idea? What time we get out of here at 50, right? And it's 8:39. Okay, my watch is just like, it's not even on the right hour. No wonder I'm confused. I was trying to hurry because I thought I was about to run out of time. What do you think I could do here? Any ideas? Good. In the numerator, what if I factored out a cosecant theta? So if in the numerator, if I factor out and I get cosecant theta, that would leave me with cosecant theta plus what? 1 all over 1 plus cosecant theta. Then what? Then these cancel out, and your final answer after all that mess is just cosecant theta. So all along the way, let's say 30 is pi halves. If I substituted in pi halves at any given point along here, that answer is going to be the same as cosecant of pi halves, right? This just simplifies it down. Now, this one was kind of a little bit more long and involved. The ones that you're going to have to do today on your own, most of them aren't that complicated, but you're going to have to think about what would make the most sense. And sometimes you don't make the best decision, right? And sometimes it might be 2 steps longer than what your neighbor did, and that's okay. These are pretty basic this time. They're going to match up with, some of them are just going to straight up match up with what's on the front of your notes, but make sure you can read what's on the front of your notes, okay? Do you have any questions? No? Okay. Well, good. So since we do have 10 minutes left, because I thought I was about to run out of time, you will have some time to get started on this to be able to practice on your own, which is what I wanted anyway, but I didn't really give you time for that because I thought I was running out of time.